Hi everybody, so last time we finished the addition of whole numbers. What are the whole numbers? Whole numbers are the numbers that you can count and zero to it, right? So counting numbers are the natural numbers. Counting numbers start from 1, 2, 3, 4. And if you have zero to it, it becomes whole numbers, right? So whole numbers start from 0 and keep going on and on and on, like 0, 1, 2, 3, 4, 5, 6, right? So we did the addition of whole numbers, and today we're gonna start the subtraction. Gets a little bit harder, but not too bad, right? So yeah, to teach subtraction, we need to also use models first. Well, students love to have hands-on in physical manipulatives, tangible, manipulatives, tangible objects. So we're gonna use our actual blocks or counters to show the takeaway model, subtraction model. The first one is takeaway model. So to model addition, we can imagine a second set of objects as being joined to first set. So we're going opposite direction. So in addition, you had two sets, one set and two sets, combining them together. But they are already combined in takeaway model. From here, you're gonna take away one set away, right? Take that much away. So physically, you can show you had 8 blocks, and then your brother took 3 of your blocks. How many blocks do you have left? So physically, you can take away 1, 2, 3. That is -3. How many is left? 5 blocks are left, right? So here are some things that you can do. Originally, you had, let's say, 6, 7, 8, 9 counters. Then your sister came in, so you shared with her and gave her 4. So that's what your sister have. Sister has. How many do you have left? You have 5 left, right? So that is a takeaway model. Why it's not connected? Hold on. Okay. It's not letting me use it. Okay. We already did that. Why it's not going? Okay, sorry. And we can also do the number line model, right? Number line, we know when we are adding numbers, we went to the right hand side. So we had 2 plus 3 is equal to 5. But here in subtraction model, you start from the beginning number. The beginning number, the number that is subtracted, is called subtrahend. Okay, so starting from subtrahend, you start from 5. Remember, we start from 0 and hop to 5. That's your subtrahend. Then take away 3. So go back to the left by 3 and you land there. That becomes your difference, the answer, right? The number you are taking away is called minuend. Subtrahend and minuend, and the answer is the difference. Subtrahend, minuend cannot be switched. In addition, we use the commutable property, so both add-ins, the numbers that you added together, can be switched around. But in subtraction, that commutable property doesn't work. So you cannot mix subtrahend with minuend. Okay, and I am emphasizing these words subtrahend and minuend because it is very precise, and if you are using those words, students can use that words too, and they can comprehend what they mean a lot more, and they can distinguish one from the other. Okay, so I strongly encourage you to use subtrahend and minuend, and the answer is the difference. Okay, So whoever were your students, they know those difficult words. Oh, how cool is that? Okay, so let's look at this number line model again. So starting from 5, take away 3. So you're not going to the right hand side, but you're going to the left hand side by 3. 1 hop, 2 hops, and 3 hops. Where you land, that is your difference. So it is 5 minus 3 is equal to 2. Make sense? Okay, so here are the number lines that you can use too. You can always extend this to the integers from the whole numbers. Okay, I will not do this now because we have done that a lot of times. Okay, so another model is missing addend model. So this is not a subtraction context. If you are reading this context, it's actually addition context. But we are using subtraction to find the answer, right? So let's look at this. Suppose set A has 8 blocks, but only 3 are visible. How many blocks must be in the set to have a total of 8? So you have one whole part, one whole thing, and one part is 3 that is visible, and the rest of it is covered, right? You're gonna find out how many there are. So there are a lot of strategies to find the answer of this blank. A lot of students will do count on from 3 and say 3, 4, 5, 6, 7, 8, counting their fingers. You cannot see my finger counting here, but you can do that using your fingers. And I just counted 5 of my fingers. So yes, the answer is 5 here, right? That 5 is coming from 8 minus 3. That is missing addend that you can use subtraction even if it is addition situation. Kind of confusing, right? So to find the answer, students can use addition using adding on, or they can do subtraction to find the missing addend here. Okay, just like this. So 3 are visible. Among the 8, how many are there? 3, 4, 5, 6, 7, 8. So I counted 5 of them. So there are 5 that are invisible. Or you can do 8 minus 3 is 5. Okay, so that's a subtraction model. This is called the rack and rack. I love rack and racks. Some countries like I think Netherlands and maybe Russia too, they use this rack and rack a lot of times, and I really like this because it shows 5 reds and white reds together 10. So in each row they show the 10 bits. So you have 20 bits, right? You can do addition, subtraction, multiplication, a lot of things by having more than 2 racks there. So for example, you can easily make, some numbers. Let's say 7. 7 is 5 and 2. So you can say 7 plus 2. And you can see 5 and 4 more, so it's 9. Or you can just add 2 more from here and see, because one's missing from 10, it's 9. Right? If you are doing the subtraction, let's suppose you are doing 10, 14 minus 7. Take away 7, 5 and 2. How many are there together? I see 4 and 1 more is 5, so 6, 7. Right? So this is so much easier, and later on students can get used to using this, and even without using actual physical rack and rack, they can imagine rack and rack use in their head, and they can just draw pictures of this in their head and calculate that. I was confused about this pencil, it wasn't working. Okay, there we go. Okay, so rack and rack is another tool that I wanted to introduce you. Okay, and there are good websites how the teachers are using rack and rack in many different ways. So please take a look at those. Okay. Okay, here is another missing add model using the number lines. So let's suppose you have same number here, but you can use 3 and how many more to make 8. To find that, you can go back how many by 5, so you can find that easily. Or you can say that 3 and just like adding on, you can do 5 more hops. So yeah, it is 5, right? So you can do that. You can also do comparison model. So let's look at this example. Suppose Juan has 8 blocks, Susan has 3 blocks, and we want to know how many more blocks Juan has than Susan. So how would you compare? I would just stack them up, 8 and 3, and see the difference by the height. Well, you can do it differently too. Like horizontally, you can pair up. So Juan's 8 blocks and Susan's 3 blocks, these two are exactly the same number, but Juan has this many more. How many are there? 1, 2, 3, 4, 5. So 5 more than Susan, Juan has, right? Fact family is really fun things that you can use, because you can use fact family for addition and subtraction and multiplication and division, right? So fact family is something very useful for students to remember, but you don't have to force them to remember that. But it's easy if they remember things like single digit fact family. You can also think about some fun games to help your students to memorize these. 7 and 5 is 12, 5 and 7 using the commutative property, it's 12. So you can find 12 minus 7 is 5, or 12 minus 5 is 7 easily. Okay, so we know that 7 plus 8 is 15, 8 plus 7 is 15, 15 minus 8 is 7, 15 minus 7 is 8, right? Same for this one. 5 plus 7 is 11, 7 plus 4 is 11, 11 minus 7 is 4, 11 minus 4 is 7. So those three numbers that you can play around for addition and subtraction. Okay, there are properties in whole number subtraction. Not all of these work. Maybe some will. Let's figure it out. What do you think? Which of the following properties hold for subtraction of whole numbers? Can you explain? Let's look at commutative property. Actually, I'm going to use my Jamboard. Okay, so in subtraction, in whole numbers, okay, commutative property, associative property, and identity property. Before we go to the subtraction, let's think about addition in whole number, okay? What is a commutative property? A number that is a whole number, this is closer, so a plus b is equal to b plus a. A and b both are the whole numbers. If you add a plus b, that's same as b plus a. For example, 2 plus 3 is same as 3 plus 2, right? Associative property, if we do 2 plus 3 plus 1, that's same as 2 plus 3 plus 1. I didn't change the order. No commute here, right? But I associated 2 and 3 first is the same as 3 and 1 first. So 5 plus 1 is 6. 2 plus 4 is also 6. They are equal. That's associative property. In addition, identity, 2 plus 0 is 0, or 0 plus 2 is also 0. So when you're adding by 0, you get yourself. That's identity in addition. Now let's go back to the subtraction. When you are in subtraction, does commutative property work? So for example, 5 minus 2 is equal to 2 minus 5? Yes or no? No. They are not equal. 5 minus 2 is 3. 2 minus 3 is negative 3. So when you are thinking about the number line, 2 minus 5, let's say this is 1 and 2. 2 minus 5, you go to the left by 5. 1, 2, 3, 4, 5. Where do you land? Negative 1, negative 2, negative 3. This is negative 3, right? So the commutative property doesn't work. Hey, by the way, is negative 3 a whole number? No, it's not, because the whole number starts from 0 and going to the right hand side by 1, 2, 3, 4, 5, like that. Right? So negative 3 is not even a whole number. So the closure doesn't work. So we don't even have to think about all these. It doesn't work for any of these. But just in case, let's check. So, associative property. Let's see if it works. I'm gonna start with a big number, like 9 minus 2 minus 5. That's what? Is this same as 9 minus, is this same as 9 minus 2 minus 5? 9 minus 2 is 7. 7 minus 5 is 2. Good. 9 minus 2 minus 5. What's 2 minus 5? That's negative 3. We did that up here. It's equal to 9. Negative negative makes positive. So that is what? 12. Hey, 2 and 12, they are not even equal. Okay, they are not even equal, associate. And also, we worked on negative numbers here. So it is not even a whole number. Okay, so it doesn't work. Identity property. Is 2 minus 0 same as 0 minus 2? Do you get yourself? Is that 2? No, it's not, because 2 minus 0 is 2, yeah, but 0 minus 2 is not 2, it's negative 2. So it doesn't work for any of these. Okay? Alright. Okay, where are we? Here. Find the solution for, now you're gonna try this, okay? Find the solution for each of the following where x is a whole number. So what whole number makes, when you're adding that by 8, you get 13. What is it? Yes, 5, right? So 5 plus 8 is 13, or 13 minus 8 is 5. You can use a lot of different strategies to find it. What goes here? 15 minus what makes 8? Yes, 7. Okay. And any number that is a whole number, any whole number that is greater than 9 and less than 11, what could that be? There's only one number, right? That is a 10. Okay. X plus b is equal to a if a is greater than or equal to b. A and b are whole numbers. So a is bigger than or equal to b, and when you are adding a number to this smaller number, you get a. So let me actually write this. X plus b is equal to a. X plus b is equal to a. So you have x plus b is equal to a. And there's one condition, right? What is bigger? A is greater than or equal to b. This is true because when you have a whole numbers, these three numbers are whole numbers, the addends are always smaller than or equal to a. Why do I say equal to? If x is 0, b and a has to be equal, or else you need to have smaller numbers of the addends to make the bigger sum, right? So we know that this is true. How do we find the x? X is a minus b. For example, if x is, x plus 2 is 5, how do we find x? We find x as 5 minus 2. you subtract 2 from each side. So in algebra, you did this a lot of times, right? Plus b minus b makes 0. So x plus 0 is x, and you have a minus b on the right hand side. So that x is a minus b. Okay, that's the fact family. So you have two whole numbers and you have a third whole numbers. The relationship here is x minus a is b, x minus b is a plus b is x, then b plus a is x. Right? That's the fact family. Okay. Okay. Now, let's try to use base 10 blocks to do the algorithm. So we did a lot of different strategies in using models. Now we can think about the algorithm shortcut. So we're gonna use the base 10 blocks. Here again, I'm gonna show you the base 10 blocks virtually. But this time I used a different website. This is apps, so I encourage you to try both of them out. Okay, and we're gonna do 243 minus 61. 240. You can do horizontally or vertically, it doesn't matter. 20, 30, 40, 3, sorry about that, 1, 2, I'm kind of slow, 3, 243, can I write down something? Yes, 243 is what I represented here, minus 61, I need to do minus 61. How can I do this? How can I do 243 minus 61? So I need to take away 61 from this. But first I can take away 1 away. And I need to take away 60, which means 10 rods, right? 6 rods. But I have only 4 rods, so I'm gonna take away 1 rod, 2 rods, 3 rods, 4 rods away, but I still need 2 more rods to take away. How can I do that? Yes, you can regroup this, not borrowing, right? You're gonna regroup this into 10 rods because it's exactly the same thing. So I'm going to trade that 10 rod, one flat with the 10 rods, because as you can see, it's gonna be exactly the same amount of that small units, right? So we are trading these two. I'm gonna delete this. Put it here. Okay, exactly the same, right? Now I can take away how many more? 2 more rods, right? Because I already took away 40. So I have 50, 61. So I'm taking away 61, and what is left is here. I wish I can move all this together. I don't think it will make me. Okay, so how many is left? Excuse me. How many is left is this, isn't it? This is how many are left. Hold on. So I have 100, and how many rods do I have? 1, 2, 3, 4, 5, 6, 7, 8. 80 and 2. So I have 182. So you have 182. So if we are connecting these two standard algorithm, I can rewrite this. Okay, so I'm going to take all of this away. Hold on. Oops. I think I can do this. Yes. Okay. So what we did here is this. Oops. 243 minus 61. We took away 1 from 3 first. So we got 2. Then what did we do? We wanted to take away 60 from 40, but we couldn't do that. We had to regroup these 200s, right? 2 flats into 100 flat and another 100 flat. But the 100 flat, we regrouped that as 10 rods. So it shows here as 14 rods. 14 tens. Now you can take away 6 tens from 14 tens. Take away 6 from 14, which is 8 tens. And this one has only 1 flat left. So that is 182. I want you to compare that small number that we put on in the addition and subtraction. So let's put some examples here. 243 minus 182. And let's do 243 plus 182. Let's look at these two numbers. I'm going to start from addition here. When we are doing that, using standard algorithm, we have 3 plus 2, 5, 1 in one's place. 4 tens plus 8 tens together, 12 tens. So 12 tens, we put one small one here, right? And we added this as 100. This is 100 because it's in the hundreds place, right? And we have 1, 2, and 1 total 4 hundreds. We said this is 100. Now here, when we are subtracting, we did 3 minus 2 as 1. And we couldn't take away, we cannot take away 8, so we can regroup this as 100s. And we regroup that another 100 into 10 tens. So here, this 1 is not 1, it's 10 tens. Does it make sense? That's why I'm writing this small one a little bit in front of 4, not right above it. Because this is 100 and that's 200, same digits. I put it right above so I can get to know this is hundreds, that's hundreds, that's hundreds. But this one is 10 tens, so it comes a little bit before these digits because it's 10 tens, so this makes 14 instead of 5. Does it make sense? Okay, so 14 minus 8 is 6 tens, right? 6 tens, and 100 minus 100, 0. So it becomes 61. So you can see that this small one represents 10 tens. So this becomes 14. But here in addition, it was the same digit here. Okay, I think that's very important. So I wanted to emphasize that. Okay, so we already did that, right? Regrouping stuff. Okay, so take a look at that too. And subtraction algorithm, we're still working on that. And here, let's see what's going on here. The compensation work. Okay, so equal addition algorithm is one of the algorithms that we can think about, or I will call that not algorithm, I will call that a strategy, the compensation strategy. So it's very easy if your number is like ending with the zeros, because think about it. If we are taking away 163 from 255, I need to calculate that. But if you have 170 instead, it's a little bit easier to take away 0 from 2, right? Rather than 5, 3 from 5. So we're gonna use the compensation method here. 255 minus 163, make this 163 the minuend easier number. It's the easier number is taking away 170 or 160. In this case, we change this to 170. So you add the 7 here, but why do we add the 7 in the subtrahend again? I want you to think about it. You got it? Yeah, because you have subtraction here, minus here. Then, using the distributive property, you can do minus 163 and also minus 7. So plus 7, minus 7, nothing. Okay, so that's how it compensates. So if you are increasing subtrahend, you can increase exactly same amount in minuend. Then the difference doesn't change. Okay, so that's another strategy. So you added 7 here to subtrahend to 62 minus 170. Using your common sense, you can think about that too. You are increasing the number you are subtracting. Then you can increase exactly same amount that you are taking away, right? Then it's gonna be the same. So you have a 262 minus 170. It's a little bit easier, but still I wanna make it easier number. So I'm gonna change this to 200. By adding this by 30, then you can add 30 to the subtrahend too. So you can have 292 minus 200. That is 92. Okay? So that's one nice strategy that you can think about. You can also think about counting up. We talked about that earlier, but always to make it easier number. For example, to subtract 31 from 100, you can change 31 to 40. What did you do here? You added a 9 to it, right? And you got 40. To come to 100, you can add 60 more. What did you add so far? 31 to 9 and 40 to 60. So 69 is added. That's how much exactly you subtracted. Let me explain this a little bit better. 100 minus 31. So 100 minus 31. Right. Okay, so to find this, you can think about partial sum. So you have 31 here, and you are adding some number, and you get 100. It's exactly the same thing, right? Remember the fact family, right? So you're gonna find what is missing addend here using the missing addends model. And then you can just do 31 plus 9 is 40. I'm getting close, right? Close to 100. From 40, I just need to add 60 more. That makes 100. So starting from 31, let me use different color. Starting from 31 to end to 100, what did I add? I added 9 and 60. So that is what is missing here, 69. Okay, here, very important thing that I need to emphasize. When I was writing this, I was very careful about using equal sign. Sometimes students are doing 31 plus 9 is 40 and 40 plus 60 is 100. Is this correct? Yes or no? No, it's big no. Never do this. Never run on. Okay? Because look, it's equal. Equal means this and that is equal, and that and equal. But look, are these two equal? 31 plus 9 is 100? No, it's 40. 40 and 100 cannot be equal. So you don't use equal sign like that. This is no, no, no. Okay? So you need to rather do 31 plus 9 is 40. Then rewrite 40 and 60 is equal to 100. Okay? Be careful about that. Okay, that's very important. Alright. And we're moving on to the next slide. Okay, we're gonna do mental computation. Okay, just like addition, we can do mental computation and estimation. And there are some strategies, right? Breaking up and bridging, you can decompose the numbers, subtrahend or minuend, to make it easier number, right? So taking away 36 from 67, maybe you want to break up 36 with 30 and 6, decompose 36 into 30 and 6, and take away 30 from 67 first to get 37, then take away 6 from 37, then you get 31, right? Trading off, we already talked about it. Trading off is compensation. If you are adding 1 to the, we always make the minuend to an easier number rather than taking away 39. I mean, that's because rather than taking away 39, it's easier to take away 40, right? So we can change this to 40 by adding 1 to minuend. Then you need to add exactly same number on the subtrahend. That's because the minus here, right? Then minus makes that plus 1 into minus, so it's balancing out. All right, so we can do 72 minus 40, which is 32. Drop the zeros. So instead of looking at 8,700 minus 500, you can say, well, 87 hundredths minus 5 hundredths. So 87 minus 5 is 82. So it's 82 hundredths, which is 8,200. Drop down the zeros and put it back on. Okay, try this. Perform each of the following computations mentally and explain what technique you use to find the answer. Which one are you using? Okay, let me copy this down and we can do that together. But in the meantime, I want you to calculate this mentally. Okay, let me oopsie, let me go to the Jamboard, and the numbers were 3,679 minus 474, and another one is 2,500 minus 700. Okay, you're gonna do these two. How would you take away 474 from this? Well, you can do standard algorithm, right? 9 minus 5, 4 is 5, 0, 2, 3, so 3,205. Well, it's not that bad, right? So you can do that. Or what else can you do? What if you are making this to easier number by adding 6 to it? Then you can add 6 to this as well. So you have 3,685 minus 480. Is it better? Well, I still don't like it. Then you can just add 20 to it to make this as 500. Then you can add 20 to this one as well. Then you can have 3,705. Now it is easy, right? So take away 500 is 3,205. 3,205. That's one strategy that I would use. How about you? How about this one? The easiest is, I think, dropping zeros down. So 2,500 minus 700 is 25,700. So I can say that is, what, 1,800? Okay. So that's mental computation. And we can also do some real-world situation problem. Like this. A store is having a sale on jackets. A jacket is on sale for $197 less than original price, right? What is the sale price? So original price was 352 and you're taking away 197. If I ask you to estimate the amount that you have to pay, how would you do that? Pause the video, think about it. What I would do is, I'm gonna change this to 200 by adding 197 to 3, and I'm gonna do the exactly same thing here. So 355 minus 200, 152. That's how much you're gonna pay, right? Okay, you can also check your answer using standard algorithm, using pencil and paper. Okay, and next video will be multiplication. Have a great day, guys.